problem? The dino-dooming asteroid just didn't have enough mass to completely destroy the planet. The asteroid was a little bigger than Mount Everest, which sounds impressive until you step back about 200 miles.
If we had a globe that was actually to scale, you wouldn't be able to feel the Himalayas with the tips of your fingers. They look huge to us, but compared to the actual size of the Earth, they're like anthills.
We need something at least half the size of the Earth and 1/10 as massive, heading for us at 30 miles a second. Let's try Mars.
You could change Mars' orbit, throw it inwards, and lead to the doomsday impact. Even as they approach each other, their own gravities are going to pull each other together in a final death cling.
As the red planet fills Earth's skies, enormous tsunamis obliterate islands and coastal cities. Then, things get very bad.
If you live on the side of the planet where Mars hits, instant vaporization.
The side that doesn't get hit is struck by continent-cracking earthquakes. The heat from the impact turns every forest into an inferno. Molten mountains of Earth and Mars, thrown into space, rain back down in an apocalyptic shower of destruction. An hour after impact, whatever lived on the surface of the Earth is dead. But Earth is so big, 6 billion trillion tons of rock and metal, that even a direct hit from Mars would leave the planet itself damaged, but essentially intact. Really destroying the Earth requires something bigger hitting us, like our sister planet, Venus.
You're talking a very similar diameter, and you're talking over 80% of the mass of Earth. So if Venus comes at us and hits the Earth, we're toast.
Both worlds shatter. Huge fragments shoot into space. But planetary rubble will also fall back and coalesce into an Earth-Venus amalgam, bigger than either original planet and as dead as the Moon. Definitely a good way to destroy the Earth. But how likely is it? 4.5 billion years ago, something as big as Mars did hit us. The early molten Earth was still cooling when a smaller planet struck us hard.
It's like a ball hitting in the sand, knocking a bunch of particles.
The object blew off part of the Earth's crust and formed a disk of debris around the Earth. From that debris, the Moon formed quite shortly thereafter.
But while planetary impacts are possible, Venus is more than 23 million miles from Earth, and Mars is at least 35 million miles away. So how would you get them from there to here?
Planets are normally in very stable orbits. But what if something happened that threw a planet completely out of its normal orbit?
Mercury, the innermost planet to the Sun, has a rather elliptical orbit. It's subject to various gravitational perturbations by other planets. Such changes in Mercury's orbit can also indirectly affect the orbits of other planets, and in particular, Mars could take on a trajectory that could someday intersect the orbit of the Earth.
Some say the odds of a real-life Mars-Earth collision are 1% over a period of 4 billion years. Not likely enough to worry about, but not impossible.
Imagine that there's a single fly in this entire stadium, and it's flying from goalpost to goalpost. If I just go like this with my hand, what are the chances that I'm going to catch that fly? You wouldn't say it's zero because there's no real reason why it can't happen, but you would say it's extremely small.
Planetary impact is one way to destroy the Earth, but we're just getting started.
Now, if you want to have a longer, slower, more painful process, then perhaps you end up having the Earth's orbit modified somehow so that it ends up moving outwards from the sun.
Welcome to the number 9 way to destroy the Earth, the Big Freeze. Under normal circumstances, our elliptical orbit takes us 3 million miles farther from the sun in July than in January. The reason it's warm in July north of the equator is because that's when the northern hemisphere tilts towards the sun. If we spun the Earth away from the sun at 3 million miles a year, the journey wouldn't be instantly fatal.
If we move a little bit, we can deal with it. We wear more jackets. If we keep moving farther out, then things start to get uglier.
At almost 200 million miles from the sun, the light is only about 1/3 as bright. This would kill off most crops.
The whole food chain would be broken down if the Earth were to go zooming away from the sun.
If you really play this game, if you get out at the orbit of Neptune, say, you might start freezing out most of our atmosphere.
A nice day is 350 degrees below zero. Nothing survives on the icy surface. The oceans are frozen graveyards. But 2.5 miles below the surface, the water is still liquid, thanks to the heat from undersea volcanoes. Sulfur hydroxide from these hydrothermal vents will continue to feed large tube worms and other exotic forms of chemosynthetic life. Continuing heat from the Earth's core may also help humanity survive in cities below the surface.
Mankind is a very resilient species, and if the Earth were spiraling out on this freezing death orbit, then I think it's very likely that we would find ways to dig in underground. You could use the geothermal energy to convert some of the frozen materials back into the liquids and turn some of the water into oxygen and gases that you need.
Subterranean farms might support a few million people. It might not be pretty, but the planet, and at least a fraction of its people, could survive. But that's not the case with the number 8 way to destroy the Earth, zooming toward the sun and the Big Burn. Imagine getting 3 million miles closer to the sun every year. The term global warming doesn't even begin to describe the situation. Liquefying polar ice caps? That's just the first few years. The sea level may rise 200 feet, but all that water is about to turn to steam.
If you move to where Venus is, 1/3 of the way in towards the sun, you're going to get to the point where you start losing the liquid water and it's going to be going to vapor. You end up having a carbon dioxide atmosphere and you have a massive greenhouse effect and you end up with a hotter surface than you even would if you had no atmosphere.
From Alaska to Australia, the average temperature is 900 degrees Fahrenheit. All complex life is dead, and the planet itself is headed for a final plunge into the nuclear heart of the sun. Astronomers and astrophysicists have come up with 10 ways to destroy the Earth. And after being smashed and slowly frozen, the planet's on a death spiral into the sun in the number 8 way to destroy the Earth, the Big Burn. Dead, barren, and choked with greenhouse gases, the Earth is now just a few million miles away from the star that once gave it life.
Eventually, all that we would have left would probably just be a big ball of burnt, charred cinder that's moving closer and closer to the sun. And as you got really close to the sun, even that would be vaporized away.
The vapor is going to be moved away by effects like the solar wind. You're going to strip it off. And I suppose for some brief period it would look like a comet.
At last, only the core remains. A 4,300-mile wide ball of iron, nickel, and radioactive metals, as hot as the sun's surface, but 2 million times smaller.
And that's what would end up actually colliding with the sun. And the sun probably wouldn't even hiccup or cough.
To change our orbit so fatally would probably take nothing less than a runaway sun from many light years away, disrupting the gravity of the entire solar system.
The chances that a star will come by sufficiently close and do that are very, very small. But it's not inconceivable that sometime in the next few billion years that will happen.
Disrupting the Earth's solar orbit means a long, drawn-out death. But stopping its rotation would be a very violent end. That's the number 7 way to destroy the Earth, stopping the spin.
If you stop the Earth, but not the objects that are standing around on the Earth, those objects would keep on going. So, for example, you would get thrown at a wall at a really high speed.
The Earth is moving about 1,000 miles per hour. And if you suddenly stop, the atmosphere wouldn't necessarily stop with it. And so instantly you would have 1,000-mile-an-hour wind everywhere on the planet at once.
At the exact same time, vast amounts of built-up rotational friction would be released as tremendous heat.
You would have rocks melting, you would have buildings melting.
Soon, the Earth would be a dead world orbiting the sun.
Our day-night cycle would be dictated by the year, the time it takes for the Earth to orbit the sun. And a day would be half a year long, and a night would be half a year long.
One side would absorb the sun's heat for 6 months at a time, while the dark side would lose heat. There would be 2 seasons, bad and worse.
This difference between the hot side and the cold side is going to end up creating massive wind jets streaming from one side to another, massive convection currents.
From pole to pole, the shadow area between the light and dark sides would be filled with massive cyclones. As the Earth moves around the sun, the 2 12,000-mile bands of extreme weather would churn across the globe.
So every 6 months, every spot on the Earth will have a cyclone season.
Basically, big old hanging mess.
It's a mess that's hard to engineer in reality.
You might imagine it happening if something were to collide with the Earth in just the right way, in such a way that balances the tendency of the Earth to rotate and so on. That collision would have so much energy that the stopping of the Earth wouldn't be our main concern.
As awful as stopping the Earth's rotation might be, it at least leaves our planet as a member of the solar system. But there are dangerous forces out in space that can remove every physical trace of Earth. Like the ultra-dense remnants of collapsed stars called black holes. A black hole's greatest area of danger is its event horizon, a gravitational point of no return.
If something is crossing it, there is no way that it can go back out. It sucks the space-time around it towards itself, so that matter just present in that space-time also gets sucked into the black hole.
A typical stellar mass black hole weighs in at around 5 to 10 times the mass of the sun. Putting something like that next to the Earth would certainly destroy the planet. But let's make it more interesting.
What if the Earth were between two black holes? With two black holes, you'd have double the fun.
And that's the number 6 way to destroy the Earth. Torn between two black holes.
One of the black holes would pull on the near side of the Earth more than on the center, stretching it out. It would also pull on the center more than on the far side, stretching it out as well. The other oppositely directed black hole would do the same thing.
The black holes wrench the Earth's crust, lifting tectonic plates and distorting the semi-solid lithosphere below. Molten magma triggers apocalyptic volcanic eruptions, and the black holes keep most of the ash and dust from falling back to Earth. In the oceans, huge tides rise and never fall. As parts of the planet fall into the black holes, matter and gases turn into deadly energy.
The stuff falling into the black hole will be bursting out X-rays. And these X-rays would flood the planet and kill everybody pretty quickly.
Meanwhile, Earth is being stretched to its breaking point.
They would be stretching the Earth in opposite directions, and it would be like that famous business of tying horses to the forelimbs of someone, tearing them apart.
Will the stretched out planet forever link the black holes? Or will it snap in half? On the list of 10 ways to destroy the Earth, number 6 finds the planet in very bad shape, torn between two black holes. It's a gravitational tug-of-war, with Earth as a rope that can't withstand the strain.
You would have a case of extreme spaghettification. Earth would be pulled in each direction, stretched in two directions toward both black holes, and eventually ripped apart. And then those pieces would get ripped apart. And those pieces would get ripped apart.
After the last spaghetti strands of Earth are violently sucked into the event horizons, the two black holes will be bookends on the empty shelf where Earth once stood. It's comforting to know that the odds of being stretched between two black holes are slim to none. But physicist and science fiction author Travis Taylor, who's written several books on real and imaginary threats from outer space, has another idea involving destructive black holes.
If I wanted to destroy the Earth, my favorite is that we trap a black hole in the core and eat the Earth away. So I would like to be on a spaceship way away to watch it collapse on itself.
And that's the number 5 way to destroy the Earth, devoured from within. A stellar mass black hole would do the job quickly, but there are other intriguing possibilities.
So, what else can we think of? Well, maybe the black hole is the size of my earring.
A black hole that size would have the same mass as the Earth itself. Let's take the miniature black hole and drop it through the North Pole. Assume the speed and angle are just right to have it end up rotating in the center of the Earth. Right away, we'd know something was very wrong.
If you have somehow managed to get an Earth mass black hole at the center of the Earth, then on the surface of the Earth, we would suddenly feel twice the effect of gravity.
All of a sudden, a ball would drop much faster.
All of us are going to start hunching down.
While all living things struggle helplessly, the miniature black hole is sucking in matter. the more it eats, the closer Earth comes to doomsday.
And as it's pulling the material in, all the material above it is going to be collapsing. So we will be having enormously massive earthquakes going on, shifts in the crust.
There'd be new volcanoes because new places where the magma can pop out or would appear due to this black hole. So one can imagine all kinds of exciting scenarios.
After months of increasing cataclysms, the finale will take less than an hour.
The Earth will start to collapse on itself, and then that part would be eaten by the black hole too.
Perhaps the Himalayas will be the last place on Earth to survive before they too fall through the event horizon to disappear forever.
If you were up in a spaceship and watching it, it would probably look like you took an eggshell and somehow crushed it from the inside out. If you could attach a string at every point to the inside of the eggshell and yank it all at once, you would see it just immediately collapse on itself.
All that would remain is the black hole. The mass of the Earth would just exist now inside that black hole.
No one has ever found an Earth mass black hole. Normal black holes only form from the supernova death of stars that were at least 10 times more massive than the Sun. But black holes with 1 million times less mass might be out in the universe. According to one hypothesis, shortly after the Big Bang, there was so much matter packed so densely together that millions of miniature so-called primordial black holes could have been formed without the need of dying stars.
We don't know of the existence of such black holes, but they could exist and they could devour the Earth.
Probably we don't want to go and find one of these just to try it out.
But could we create a mini black hole right here on Earth? Perhaps with a particle accelerator like the Large Hadron Collider in Europe? That's what Justin L. from Salt Lake City, Utah wanted to ask the universe. So he texted us. Can a super collider cause a black hole?
Justin, great question. A lot of physicists would like to know whether the Large Hadron Collider will produce mini black holes. In principle, it can if it compresses a lot of material into a sufficiently small volume. Then it'll produce a black hole. But don't worry, such black holes will quickly evaporate and they won't devour the Earth.
In space, the destructive power of black holes comes from their irresistible gravity. But a lack of gravity could be even more dangerous for the Earth. That's what intrigues astronomer Alex Filipenko, whose groundbreaking studies of dark energy and the acceleration of the universe have inspired his own vision of doom.
Perhaps my favorite way to destroy the Earth is through a disruption of what we call gravity.
And that's the number 4 way to destroy the Earth. Turn off the gravity. Everything we do depends on a balanced relationship with gravity. But what if gravity decided to end the relationship? Without gravity, what goes up will never come down. Airplanes will never land. Trees are rooted to the ground until the ground comes apart. And all that is just a warm-up for the real disaster to come. Earth itself would begin to break apart, piece by piece. It seems impossible. But could gravity really be switched off? Incredibly, the answer is possibly.
In the future, gravity may cease to exist.
Of the 10 ways to destroy the Earth cooked up by astronomers and astrophysicists, one of the most incredible is number 4, turn off the gravity. Today, gravity is one of 4 basic forces. Along with electromagnetism, the strong nuclear force that holds atomic nuclei together, and the weak nuclear force that's the source of radioactivity. But at the time of the Big Bang, instead of 4 fundamental forces, there may have only been 2.
When the universe was a tiny fraction of a second old, the strong nuclear force was unified with what's called the electroweak force, an amalgam of electromagnetism and the weak nuclear force.
That united superforce may have created a super energy that could have caused an almost instantaneous expansion of the universe, called inflation.
It became monstrously big in a very short amount of time.
But in a minuscule fraction of a second after the Big Bang, inflation stopped as the forces broke up.
The strong nuclear force split apart from the electroweak force, becoming 2 different manifestations of this previously unified force.
If a seemingly unified force could split in 2, can it happen again with gravity? This terrifying possibility can be represented with a simple coin. A quarter has 2 faces, but if you impart energy to the coin by spinning it, the 2 faces seem to merge.
You see neither heads nor tails distinctly. Now, eventually, that quarter loses energy and it lands either heads or tails. 2 distinct outcomes, neither of which looked like the spherically symmetric spinning quarter. In the same way, the symmetric gravity right now could someday split into 2 different aspects. Each of these 2 new forces would behave in a way distinct from the current behavior of gravity. Everything that's held together by gravity would disintegrate. And that would spell doom for us on Earth.
Human bodies would remain intact because they're held together by electromagnetic forces, not gravity. But everybody on Earth would fly up to suffocate in space, while the Earth itself would come unbound, no longer held together by gravity. Jupiter and the other gas giants would dissipate. The Sun, whose gravity once spun the planets like balls on strings, would fly to pieces.
Most of the sun is all big hot ball of gas anyway, and it's held there by its own gravity. So what you would probably see is a star drift away rather quickly.
The sun wouldn't be held together, the galaxy wouldn't be held together, everything would be drifting apart.
The Earth would be just random particles in a small corner of a universe of cosmic dust.
That would be a pretty amazing ending.
Of course, there is another way to take the Earth apart. Blow it up. Easy? Of course not. But there is a way.
Create an antimatter devastation bomb of some sort.
That's the number 3 way to destroy the Earth. Antimatter annihilation. And it's the first choice of astrophysicist Clifford Johnson.
The antimatter idea just has a certain beauty to it. It's just the sheer, terrible beauty of a really dramatic explosion from the inside.
Antimatter is just like matter, only the opposite. And matter and antimatter destroy each other in a blaze of glory.
So basically, this is Einstein's equals mc squared in action. You can take this matter and antimatter and combine it together and release pure energy.
Just 1 pound of antimatter, annihilating 1 pound of matter, would pack 44 megatons of explosive punch, as much force as a thermonuclear bomb. But destroying the Earth would take a lot more. According to some estimates, you'd need at least 100 trillion tons of antimatter.
So, thinking of the size of the stadium, we would have to fill millions of stadiums with antimatter before it could interact with the matter on Earth to actually release enough energy to unbind it.
But if you really want to try, there's an antimatter factory just 93 million miles away. When enough magnetic energy builds up in the nuclear furnace of the sun, it's released in an explosive solar flare. A big flare can generate as much as 2 pounds of antimatter. Contact with matter destroys the antimatter almost instantaneously, but there are ways of containing it.
You can suspend it without touching it by using various kinds of electric and magnetic fields. So you can keep a quantity of antimatter suspended indefinitely.
So all you have to do is collect and store antimatter from around 100 quadrillion solar flares. Once you've got your 100 trillion tons of antimatter, just transport it to Earth and turn off the electromagnetic field so it can come in contact with normal matter.
Maybe put it at the center of the Earth somehow, and then let it do its thing. It'll explode outward and simply rip everything apart.
But while an antimatter explosion would be instantaneous, collecting all that antimatter would take tens of billions of years.
We only have so many solar flares a year. It would take many, many, many years to capture and store enough antimatter to really create a very appreciable sized bomb.
Physicists know that antimatter isn't the only type of particle that could liquidate the planet. The number 2 way to destroy the Earth is a case of destruction through transformation, transformed by strange matter. This is big trouble that starts at a tiny level, smaller than protons and neutrons, in the weird world of quarks. Particles with names like up, down, and strange.
Try not to get hung up too much on the semantics of what a quark is. You might want to say it's a subatomic particle, the thing that makes up the other things.
Some physicists theorize that an equal number of up, down, and strange quarks would make up a strangelet, a particle of something called strange matter. What makes it so strange is that it might change the physical nature of whatever it touches, like ice cooling the water around it, only far more extreme.
They like to turn other things into strange things. They like it all to be strange.
Imagine everything on Earth and the Earth itself turning to inorganic mush, all because of a subatomic strangelet. Fortunately, there aren't any strangelets on Earth. But inside the collapsed suns called neutron stars, it might be possible for the immense gravity to press together up, down, and strange quarks into strange matter.
We are getting very close to the answer. We might know in the next few years.
So if you did find a microscopic lump of strange matter in a neutron star, somehow got it back to Earth and dropped it, say on the top of the Empire State Building, what would happen? A, nothing, or B,
All these strange quarks could change the state of matter here on Earth.
a chain reaction has begun. The strangelets are reacting with ordinary matter. The Earth is changing. But into what? On the list of 10 ways to destroy the Earth, number 2 is perhaps the strangest of all. Transformed by strange matter.
If you wanted to convert the entire planet into a big bunch of strange quarks, all you would need to do is put a few strange quarks here and there, then the Earth would start turning itself strange. Even more strange than it is.
Strange matter, a lump of quark material called strangelets, has been let loose on Earth. And an astonishing event happens. The first thing it touches turns to strange matter. Then the next thing.
Pretty soon, you would be a strange version of yourself.
Even when we look at subatomic levels, just at the nucleus, there is a well-defined structure. We can tell apart protons and neutrons, etc. But if you lost that structure, then matter would lose the shape that we know of.
The unique orbits and numbers of particles that make up the individual elements now form an undifferentiated mass. Everything becomes the same strange matter, from atomic nuclei to monuments and mountains. And whatever is alive dies.
And once it starts, this transition would be fairly rapid. It would be like dissolving something into one huge glob of matter. It would turn into just this goo, this soup of quarks.
You could end up converting the entire Earth into one big piece of strange matter.
Primordial black holes, the end of gravity, antimatter and strange matter. Does theoretical physics have an even more bizarre way to destroy the Earth? Yes. In fact, astrophysicist Farial Ozel is ready to obliterate the Earth, along with the entire fabric of reality.
I think my favorite way of blowing up the Earth would have to be some kind of huge phase transition in the universe. This would just take us into another state.
It's the #1 way to destroy the Earth, when parallel worlds collide. It starts with another science fiction staple that many physicists now take seriously: the existence of other universes.
It's possible that there are Earths in other universes.
Think of our universe as a two-dimensional sheet which exists here, and moving around in the sheet is like moving around in our 3 spatial dimensions. But then you can move in this other direction, which is sort of off the sheet. And there's another sheet there, and that would be a different universe. Our universe would be just like that one, perhaps, or maybe slightly different. But it's very important to realize that we shouldn't have these two things collide into each other.
Imagine that our universe is a piece of paper, like this. Then a nearby universe would be this piece of paper. Now, if the two pieces of paper were to collide, you could hear that energy. Now imagine 2 sheets of paper the size of a universe colliding. How much energy would be imparted at a collision like that?
If we somehow did make contact with a parallel universe, it could be the last thing we'd ever know.
It would not just destroy planets, it would destroy solar systems, galaxies, clusters of galaxies. It would destroy everything.
It would be the end of this current universe.
But is it possible that the end of everything is the beginning of everything else? An object half the size of a football field plunged down from space at around 34,000 miles per hour and produced a stream of fiery gas behind it. Within minutes, the fireball entered our atmosphere and violently exploded above Siberia's Tunguska forest. It became the largest explosion on Earth in modern human history. The blast sparked heat waves which torched 80 million trees in an area over half the size of Rhode Island. Fortunately, no one died as a direct result of the explosion because it was in a thinly populated area.
If that asteroid hit just a few hours later, it would not have hit Siberia, it would have hit over Europe. And if that had exploded midair over any of the major cities of Europe, 1 million people would have died like that.
For the last 100 years, the Tunguska explosion has been shrouded in controversy. Today, many scientists agree an asteroid caused the blast. Incredibly, it never even impacted the ground. Rather, it exploded 5 miles above Siberia's frozen ground.
A small stony asteroid can't survive the plunge through Earth's atmosphere. When it smacks into the lower atmosphere, doing about 50,000 miles an hour, it's like an egg smashing onto concrete.
The blast over Siberia released energy equivalent to 15 megatons of TNT, 1,000 times greater than Hiroshima. If this were to happen over a large city, it would annihilate it. Scientists call these trespassers near-Earth objects, or NEOs. They're asteroids and comets, which are leftovers from the formation of the planets. Comets move in the Oort cloud and the Kuiper belt, which is beyond the planet Neptune. Asteroids travel in a band between Jupiter and Mars, but their orbital trip isn't always routine.
Most of the asteroids orbit in a neat belt between Mars and Jupiter, and we don't worry much about those. But when one gets away and all that mass and energy is headed towards Earth, that's when the astronomers start to worry.
Oftentimes, these cosmic remnants get bumped out of their orbit and head on a collision course with Earth. Our planet's thick atmosphere vaporizes the vast majority of them. But a larger object can knock through our atmosphere and actually impact the ground.
If you want to turn to the cosmos and look at the forces that would have us dead, asteroids striking are real and they're bad. It's happened before, it will happen again.
65 million years ago, an asteroid the size of a small city plummeted down from the sky. It exploded in the Yucatan Peninsula near the present-day Mexican village of Chicxulub with the force of 100 million megatons of TNT.
It hits the Earth, casts billions of tons of Earth's crust into the atmosphere, cloaking Earth, blocking out sunlight, knocking out the base of the food chain, and sending a wave of extinction across the tree of life.
It is believed the ferocious impact contributed to the mass extinction of the dinosaur.
We can think of asteroids as being bad things, but were it not for an asteroid, we wouldn't be here today. Our mammal ancestors were running underfoot, trying to avoid being hors d'oeuvres for T-Rex. T-Rex gets taken out. Well, this opened up an ecological niche that allowed our mammal ancestors to evolve to something more ambitious than a rodent. And out comes the primates, and among the primates we have people.
But ironically, the very kind of cosmic boulder that paved the way for humans to exist may one day wipe us off the planet. In 1998, Congress urged NASA to detect all the near-Earth objects over a half-mile in diameter or more. And what they found was unsettling. Over 850 NEOs in our vicinity. These asteroids are our closest and most dangerous neighbors in the solar system. Donald Yeomans heads the NEO program at NASA's Jet Propulsion Laboratory. He and his cosmic bounty hunters search for potential killers lurking in our solar system and put them on their most wanted list.
Finding these near-Earth objects is somewhat akin to tracking hurricanes. As you track it day after day, you get a better idea of its orbit. You can predict where it's going. You have a better idea of how large it is and if it should hit the Earth, with what sort of velocity.
By using telescopic technologies, NASA's Space Guard survey has detected over 90% of all NEOs deemed harmful. These frightening objects could strike the Earth with the energy greater than all the nuclear weapons on our planet today. Such an impact could trigger mass extinction.
You wouldn't expect one to hit but every several 100,000 or millions of years. But if one did hit, it could wipe out a fair fraction of the population. So they're very low probability events, but high consequence events.
If they hit the Earth, they would have global effects. I mean, not only would you wipe out a continent with really heavy shock waves, but the ejecta would be thrown up in the air and come down all around the planet. The atmosphere itself would get to 1,000 degrees or so, and all the vegetation all over the world where that happened would flash into flames.
Cataclysms could also occur with smaller objects. So Congress now asks NASA to locate all NEOs 500 feet in diameter, as wide as the Roman Colosseum. An object that big could decimate a metropolitan area or even a small state. And what worries scientists most is not the asteroids they've discovered, but the ones they have not yet found.
At any given time, there's about 24 objects for which we can't yet rule out an Earth impact.
Former astronaut Schweikert has taken the threat of NEOs one step further. He's appeared before Congress to request a special government agency be responsible for protecting the public from space rocks.
Today, we have the technology to stop near-Earth objects from impacting the Earth for the rest of history. I mean, we can literally now begin to reshape the local solar system so that our survival is enhanced. The question is, will we? Or will we go the way of the dinosaurs?
But Schweikert isn't waiting for NASA or Congress to solve the problem. He has his own plans to save the planet from the next asteroid impact. It's hard to believe the Earth has survived over 4.5 billion years, because since its infancy, the planet has taken a beating. Like a boxer, our world is under constant assault from asteroids that enter our orbit each year. But in the future, Earth could be knocked out. Former Apollo 9 astronaut Rusty Schweikert refuses to be bullied by asteroids. And now he's ready to defend Earth against these harmful rocks.
We've discovered that there are these near-Earth objects flying by us all the time. And we've gotten more and more capability to modify our environment to enhance our survival.
Schweikert is particularly concerned about an asteroid named 2004 MN4, better known as Apophis. This pockmarked rock, approximately 750 feet in diameter, swept near Earth in 2004. Now it's scheduled to pass dangerously close to our planet again on Friday the 13th in April 2029.
So in 2029, Apophis will come closer to us than our own communication satellites orbiting the Earth. It will be so close that people who are in the right place will be able to see Apophis go by the Earth with your naked eye. You won't even have to have binoculars. That's how close that asteroid is going to come.
Apophis has an over 99% chance of missing the Earth in 2029. But if Apophis passes the Earth at a distance of exactly 18,893 miles, it may pass through a gravitational keyhole, a narrow region in space a half-mile wide. If this happens, the Earth's gravity could upset Apophis and change its trajectory. It could cause it to return and hit Earth 7 years later, on April 13th, 2036.
The gravitational effect of the Earth will cause it to bend, cause the Apophis orbit to enlarge to precisely the size which 7 years later it will come around and hit the Earth.
At the present time, Apophis has a 1 in 45,000 chance of delivering a deadly blow in 2036. But even these odds have scientists placing bets.
It's one thing to know that there's maybe 1 chance in 45,000 that it's going to hit the Earth, but what you'd like to know, is there 1 chance in 100? Is there 1 chance in 10? Is the probability 1 that it's going to hit the Earth?
Schweikert believes we must regard Apophis as we would any natural disaster. He's even mapped out where Apophis might strike.
You have the date of the impact, the time of the impact, the orbital inclination, and you can make a map. And what that map shows is what I have called a path of risk that goes all the way across the planet. And I look at this and I see a high probability of impact and I say, whoa, you know, where might it hit?
According to Schweikert, Apophis could impact any point along this path of risk. It begins in western Siberia, cuts across and down the Pacific Ocean near California. Then it traverses Central America and finishes in Western Africa. Schweikert proposes a chilling scenario of where Apophis might strike. The asteroid could land in the Pacific Ocean off the coast of California with the force of over 1 million megatons of TNT. Such an impact would create a 5-mile wide, 9,000-foot deep crater in the water, which would unleash tsunamis. Relentless 50-foot waves would pound the coastline, resulting in unimaginable human loss.
An asteroid that's 1,000 feet in diameter, having it hit in the ocean is not a good deal. Hundreds of billions of dollars of damage from something like that.
Scientists are presently working on technologies to preempt such a cosmic strike. One idea involves blowing up an asteroid. But some feel this could compound the problem, sending several chunks of the asteroid in our direction instead of just one. Consequently, Schweikert's new mission is to change the orbit of asteroids that could impact Earth.
What you want to do is basically change the asteroid's orbit very, very slightly. You change its velocity by a 10,000th of a mile per hour so that it will miss the Earth instead of hitting it.
Rusty's colleagues have drafted conceptual designs of spacecraft that could deflect asteroids, particularly Apophis. One would tow harmful asteroids away from Earth, but instead of lassoing the rock like a bull in a rodeo, the tractor will hover in front of it and use gravity as a tow line.
If you park in front of an asteroid for a long enough period of time and you stay close enough to it but not touching it, you're going to increase its velocity. Or if you park behind it while it's moving along, you're going to slow it down very slightly. We can change the orbit of an asteroid if we know about it far enough ahead of time.
Although a space probe has landed on an asteroid in the past, the most challenging idea is launching a manned mission. Once landing on the rock, astronauts could mount a radio transponder to track its whereabouts.
You could just use a robotic mission to go to an asteroid, land, grab a sample, and bring it back. That's not that difficult. What you gain by a manned mission is they can react to interesting areas on the asteroid surface. They could go here, there, and they wouldn't have to rely on remote navigation.
Nicaraguan border.
Schweikert insists we should remain on high alert regarding asteroid Apophis, and his cause hasn't gone unheard. Now the United Nations plans to draft a treaty which will include who will be responsible for deflecting killer asteroids.
That would be a real crime if we are so irresponsible, knowing that this is going to happen, that we continue to do nothing about it.
But asteroids and comets are not the only deep space threats.
Earth has had its ups, and Earth has had its downs. We never know what's going to be around the next corner, and a lot of it is bad.
In far-off galaxies, galactic invaders are at work, itching to end life on the planet as we know it. 3 times daily, a strange flash pulsates across our sky. It's hundreds of times more powerful than the world's total nuclear armament, but it's not man-made. And if one happens close enough to Earth, it could end life on our planet. Most Earthlings are unaware of the potential hazards in space, but the list is long and growing. Imagine this. Within our own galaxy, the Milky Way, a massive star explodes, sending a lethal burst of energy rocketing toward our planet. This is a gamma-ray burst, the biggest explosion to rock the universe since the Big Bang. In the cities and countryside below, there's no warning of what's about to happen. And then it strikes.
It would be equivalent to standing 1 mile away from Hiroshima, any place on the Earth.
The potent radiation cooks the upper atmosphere. Our ozone layer roasts. Across the hemisphere, human beings burn to death from radiation 100 times the fatal dose. The disappearing ozone layer causes increased temperatures around the world, triggering cyclones, tsunamis, and hurricanes. Most life on the surfaces of land and water incinerates. This may seem like science fiction, but it could happen if a gamma-ray burst hit Earth from 100 light years away.
Gamma-ray bursts are the brightest explosions in the universe. Because they're so far away and yet still so brilliant, they must involve an enormous amount of power. As much energy as the sun will emit in its entire 10 billion year lifetime.
As a young student, Stan Woosley always liked experiments that go boom. Now, the work of this astrophysicist is more than child's play. He's one of the galactic detectives trying to uncover the mysteries behind gamma-ray bursts.
We know there are many planets and many stars throughout the cosmos, so there may have been countless civilizations that were destroyed by gamma ray bursts.
These peculiar beams of radiation were first spotted in the 1960s. At first, most astronomers believed these gamma ray bursts must exist in our own galaxy, the Milky Way, because they're so bright.
There were reasons for that. One was that if they were outside the galaxy, the energy was almost unbelievable.
But at the time, even the most powerful telescopes couldn't determine their location and distance, because the bursts lasted for a few seconds, then disappeared. But then astronomers wondered, what about their afterglow? Cosmic explosions typically leave behind some luminous residue that sometimes lasts for days or weeks. In the late 1990s, satellites used upgraded optics and X-ray detectors to finally capture a gamma ray burst's afterglow.
It became clear that gamma ray bursts actually were cosmological, coming from very far outside of our galaxy, from millions and billions of light years away, and that meant their energy had to truly be astronomical.
To get some idea of how incredibly bright a gamma ray burst is, we could represent the brightness of our sun by this relatively dim LED, and we could represent the brightness of the gamma ray burst by the very, very intense searchlight that's behind me. Isn't that incredibly bright? Unfortunately, with this comparison, the searchlight is not nearly bright enough to represent fully the gamma ray burst, and in fact we would need 100 billion such searchlights to have an adequate comparison. The gamma ray burst is equivalent to the brightness of 1,000,000 trillion suns.
These massive bursts could decimate Earth. But what causes them?
We are quite convinced that the common gamma ray burst comes from the death of a massive star, at least 10 times the mass of the Sun. And such stars are quite rare, by the way.
Woosley masterminded a groundbreaking model of how gamma ray bursts may be created. When an extremely massive star dies, it collapses into a black hole. Black holes are created when a collection of matter collapses to such a high density that light itself cannot escape. But Woosley proposes that some of the star resists getting sucked into the center of the black hole. As a result, a high-speed spinning disk of matter forms around it. Within seconds, jets of plasma shoot out from its rotational poles. These beams of energy unleash dangerous gamma rays into space.
If you can imagine just trying to squeeze a fruit or some kind of sphere of some object into a very small space, things are going to squirt out. And in this case, the squeezing is done very rapidly, and you're talking about a huge amount of mass.
At the same time the gamma ray bursts are ejected, the collapsing star explodes or goes supernova to the extreme.
One of the reasons gamma ray bursts are so incredibly bright is that they take an enormous amount of power and then they focus that power into a very small portion of the sky. For every 300 gamma ray bursts that go off, only one is pointed in our direction, and so we only see one of those 300.
Even if a gamma ray burst were to occur not 100 but 1,000 light years away, the Earth could still face apocalyptic destruction.
If a gamma ray burst happened within 1,000 light years of the Earth, then it would be approximately 500 times brighter than the Sun and emitting gamma rays. The energy delivered to the Earth's upper atmosphere would be like 100,000 megatons of nuclear explosions. The ozone would be depleted. We'd have acid rain, but we'd also have flash burns, incineration of vegetation, perhaps something resembling nuclear winter. So there could be a global extinction of many species. Now, the far side of the Earth would be a special place to be, because gamma rays don't go through the Earth, and if you were on the other side, you wouldn't get flash burned. But the effects of depleting the ozone and changing the composition of the atmosphere would eventually come to the other side, and there the effects are unknown.
Statistically, this ghastly scenario has a 1% chance of happening once in the Earth's entire lifetime. But even these odds aren't reassuring if you're living on the planet at that very moment.
If you're caught in the beam, that's a bad day for you. If one of these happens in your galaxy and that beam is coming your way, go hide in a cave, because this is very high energy radiation. It's the kind of energy that will decompose your molecules, and you just don't want to be around when that's happening.
There currently are no defense measures to shield us from gamma-ray bursts if they happen close to Earth. They travel at the speed of light, 186,000 miles per second. By the time we detect them, they will have already struck our planet.
Gamma-ray bursts could pose a hazard to the Earth or to anything living that came within their bore site, but as we've seen, they're very infrequent. And there are other things in the heavens and on the Earth that are much more dangerous.
Cataclysms routinely erupt in some corner of the universe. And one day, something will snuff out Earth.
Most of the time, our ride around the sun is gentle and uneventful like this Ferris wheel. And as long as nothing gets in our way, we could go on like this for millions of years. But sooner or later, we know that this smooth ride will come to an end. We just don't know when.
Sadly, our planet's ultimate demise will probably come from the very thing that provides us life. Earth maintains a cozy lifestyle, being third rock from the sun. For over 4 billion years, the sun has been an ally, warming and feeding our planet. But in time, our solar heater will become our enemy.
The sun and the Earth have a unique relationship to each other. The Earth has a particular temperature, it's a particular size, it has life on it, and oceans, and those things depend on the sun. The sun is at the root of the existence of life on the Earth, and the sun will be at the root of its demise as well.
Earth's relationship with the sun will become dysfunctional when our solar mother really turns up the heat.
The sun gets hotter because it's burning hydrogen into helium. 4 hydrogen atoms become 1 helium atom. That means there are fewer particles bouncing around inside the sun. And that process basically means that the sun has to get hotter and brighter to hold itself up.
As the sun's core gets hotter, its outer parts will swell in size and turn red.
If you have a bonfire, you have all this wood there, you build it up, and at some point enough logs get burnt and the thing collapses and you get this huge burst of sparks and it gets much brighter. In a sense it's like that because the sun is right now burning hydrogen into helium, and the helium is the ash of that, if you like. And then as the sun collapses enough, the ash relights and the helium burns into carbon. And that's when things get really hot.
At this point, the sun will expand into a red giant and incinerate most complex life on Earth.
When the sun becomes a red giant, it will grow to 30 times its size. So the surface of the sun will actually be out beyond the orbit of Mercury. The luminosity of the sun will go up by like 1,000 times. And that's going to make the Earth so hot that the outer crust, the rocks, the solid part of the Earth, will melt. The whole planet would be a glowing ball of lava.
The sun will fry the inner planets, and even though the sun will become red and cooler, the Earth will be much hotter. Just leave the Earth a burnt cinder, like a charcoal briquette. So that would be bad for life on Earth.
And the Earth's hellish fate isn't over. As a red giant, the sun will fluctuate in size before collapsing into a white dwarf.
The sun that was huge suddenly becomes the sun that's very small and extremely dense. It's only about the size of the Earth, sitting down there at the center of our solar system, very much fainter than it used to be, and then everything cools off. And then that object is no longer generating energy either, so it begins to cool as well. So the final fate of the solar system will be to cool off and freeze.
Humans will probably have relocated to another planet or become extinct before the sun turns Earth into a snowball. However, the sun may dry up our world much sooner.
If the sun doesn't get us at the time of the red giant phase, it may well get us earlier by just becoming bright enough to cause the oceans to evaporate. Water is an essential component for all life. And so if the Earth actually loses all its water, then that's another reason why life might disappear from the Earth, and it would again be the sun's fault.
There may be ways for Earth to win a stay of execution.
As the sun is swelling, it also begins to lose mass much more rapidly than it's losing it now. And of course, if it's getting less massive, it has less of a hold on the Earth will move further out into a larger orbit. And so it's kind of a race between the growing sun and the growing heat from the sun and the Earth actually moving, a little bit away from that fire that's getting too hot.
If our planet somehow manages to avoid getting fried or frozen by the sun, its future remains increasingly bleak.
This place is full of adventure. Rides that put your stomach up into your throat, things that collide, scary stuff. It's a lot like riding around the sun on planet Earth. But when Earth gets smacked or when things start to come apart, the ride could really be over.
I don't know what that means for the universe to end, because I like time. I live in it. So it's hard to imagine time ending.
Today, scientists contemplate our inevitable fate. In the distant future, the Earth and the entire universe may face the ultimate cosmic monster. No one suspects that Earth's most lethal enemy lurks amongst the stars. But in the future, and without prior warning, a cosmic Grim Reaper will unleash the ultimate Armageddon. The dark villain will stretch apart the universe. Galaxies themselves will split apart. Stars and planets will tear to shreds. The ultimate apocalyptic event is being called the Big Rip. And when it begins, it won't stop until every atom and nuclei in the universe are mincemeat.
The Big Rip, it really is the end of the universe. It's not like we're the last ones at the party wondering what's going on and we can go do something else. It's really like you've turned off all the lights and the universe just ends.
Innovative physicists Robert Caldwell and Mark Kamiankowski proposed the notion of the Big Rip, a grim hypothesis about the final fate of the universe.
We used to think that the universe, which is currently expanding, could reach a point of maximum expansion. The Big Rip is the idea that the expansion will not only continue and accelerate, but rip everything apart as it does so.
Caldwell and Kamiankowski calculated that the universe is expanding at an alarming and increasing pace, and that something is sucking everything outward like a vacuum. Acting like a galactic vice squad, these young scientists hunt for the cosmic killer. They believe a mysterious phenomenon called dark energy may be the culprit.
Figuring out what dark energy is probably the #1 goal of cosmologists today. Dark energy is dark, so you can't see it. We can feel what it is. We feel it through its effects on the gravitational behavior of the universe. There could be some dark energy in this room, under the chair. It's only when you look at its properties on really big cosmological length scales, billions of light years across, that you start to see the cumulative effects of the dark energy. It causes things to be pushed farther away from each other and contributes to the expansion of the universe in a quickening pace.
Edwin Hubble, whom the Hubble telescope is named after, first discovered the universe is expanding back in the 1920s. But it wasn't until 1998 when a crack team of scientists measured that this expansion is moving like a runaway train.
A nice analogy is to imagine that the universe, our three-dimensional space, is like the surface of a rubber balloon that I'm blowing up. Okay, I'm going to blow up the balloon as a demonstration of the effects of the expansion of the universe. As the balloon gets bigger, that's the depiction of the expansion of galaxies.
There's a galaxy. Another one.
Where's our galaxy?
Okay, we live there.
Okay, that's our home. As the universe expands, every other galaxy gets farther away from us.
In ordinary expansion, each galaxy stays the same size. But if you have super accelerated expansion, then the galaxies themselves can each expand, which is sort of what's happened here.
If I could blow it up fast enough to depict a big rip, then the balloon would explode. That's like space-time not being able to take it and coming to an end. So instead we'll just pop a hole in the balloon. That's the big rip.
According to Caldwell and Kamiankowski, the universe has no hope of surviving the Big Rip. They've even come up with a countdown to this apocalyptic event.
The Big Rip kind of rolls up its sleeves and progressively takes apart the universe layer by layer, working from the outside in, going from the largest scales to the smallest scales. 1 billion years to pull apart clusters of galaxies, then hundreds of millions of years to pull apart galaxies themselves, and then down to the size of a solar system, we're talking hundreds of thousands of years, and then to tear apart the Earth itself would take less than an hour. It's kind of interesting to think about what that would look like. If I'm in my protective capsule watching things happen, I would see this wall of darkness that starts coming towards us. I would no longer, at that point, be able to see any stars. The Earth, layer by layer, will be peeled off and ejected away.
Everything in us, the molecules that hold us together, would get ripped apart, and every atom that makes up your body would fly off to infinity in a very short period of time.
Fortunately, mankind doesn't need to lose sleep over the Big Rip. Caldwell and Kamiankowski estimate that it will climax 50 billion years from now, when the universe is over 3 times its current age.
What's really fun for us is to try to figure out whether this is actually what's going to happen, to paint the science fiction scenario of what might happen and to think what might happen to us.
Deep space threats are real. Some could harm us tomorrow, others in the far future. But one thing's certain, something will terminate Earth and probably the entire universe once and for all. It's only a matter of time.
It's useful to sometimes think about how fragile our life is here on Earth. that maybe we aren't going to be here for eternity. Maybe there's a hope, but the way it looks, the universe just ends.